Okay, in this video we're going to review unit circle and trig functions, how to evaluate the sine, cosine, tangent of an angle. So let's start with this example. Sine 330 degrees. Find 330 degrees on the coordinate plane first, remembering that 0 degrees is going to be the positive direction, make sure this is writing, the positive direction of the x-axis, and you rotate counterclockwise. 330 degrees would put you about here, and there would be just 30 degrees left over to get back to the x-axis. So the angle in here that I've just done in red is 30 degrees. Then I would recommend sketching a quick right triangle for yourself, always with one leg on the x-axis, never with a leg on the y-axis, and then using your shortcuts that you know about either 30, 60, 90, or 45, 45, 90 triangles. So opposite a 30-degree angle, we would label the length of that leg 1. And here it's going to be important to label it -1 because we're in the fourth quadrant where y values are negative. The other leg of a 30, 60, 90 is the root 3. And the hypotenuse of a 30, 60, 90 is 2. It's double the short leg. So with that label, you should be able to answer the sine, which is opposite over hypotenuse, as -1 over 2, because opposite the reference angle, which was the red 30-degree angle here, is -1, and the hypotenuse of this triangle is 2. So that was the way you might recognize that we did it last year. To find the sine, cosine, and tangent of 150 degrees, in this case, just added another example, 150 degrees, sketch a coordinate plane, find 150. Note that there would be 30 degrees left over here because it's 180 to get back to the x-axis over here, and then sketch yourself the little right triangle, always with one leg on the x-axis. If this is 30, opposite that we have a 1. In this case, the 1 is positive. The other leg of a 30, 60, 90 is root 3. Over here it would be negative because it's an x value on the left side. And then the hypotenuse would be 2. The hypotenuse is never negative, no matter what quadrant you're in. And then here we're asked for sine, cosine, and tangent. So we'd set up all three. Sine 150, cosine 150, tangent 150. And then we just have to remember SOHCAHTOA, right? Sine is opposite over hypotenuse, so 1/2. Cosine is adjacent over hypotenuse, so negative root 3 over 2. And tangent is opposite over adjacent. So 1 over negative root 3, but we have to rationalize that. So negative root 3 over 3. So this is asking for a little bit more concept stuff. Given that sine of theta, and theta here could be any acute angle, sine of theta is 5 over 13. And then they give us this other detail that theta is between 90 and 180. So between those two pieces of information, I can sketch it on the coordinate plane. I know it's between 90 and 180, the angle in question. So that means it's somewhere in this quadrant over here. And that's not accurate, it's just somewhere in there. And then I know that the sine of it is 5 over 13. So if I sketch a right triangle, and sine is opposite over hypotenuse, well then this is going to be the 5 and this is going to be the 13. No matter what this angle is, right? I don't know what the angle is, but it isn't asking me to find the angle. It's just asking me to find the cosine and tangent of the angle. So if I'm going to answer cosine and tangent, I can do this without a calculator. I just need to know the other side of this triangle. So I could do Pythagorean theorem. I have this one memorized, that if the hypotenuse is 13 and one of the legs is 5, the other leg is 12. And just make sure you're noting that it's negative here because we're in this quadrant. That's why they had to give us the information about theta being between 90 and 180. So we've got our three sides of our triangle. Now I can answer the sine of theta, which is 5 over 13. That was given. The cosine of theta, that'll be negative 12 over 13. The tangent of theta, that would be opposite over adjacent. So just a concept question to make sure you can interpret and use any kind of information given to you in a trig question there. Further practice, noting that a negative angle means you're going clockwise instead of counterclockwise, but other than that, the procedure is exactly the same. So starting from 0, negative 240 degrees means to go 180, 240, puts us about here. And then you're still doing the rest of the procedure the same. I care about this angle, right? The angle is between the terminal side and the x-axis. That's going to be my reference angle, which here would be 60 degrees, right? Because between 180 and 240 would be 60 degrees. And then you can sketch yourself the right triangle, noting that across from the 60 is the root 3, the other leg is the -1, hypotenuse is 2, and the tangent would be opposite over adjacent. So root 3 over -1, which we have to rationalize. Oh, no, wait, that's already rationalized. Well, that's just negative root 3, right, because it's divided by just 1. Okay, so that's a negative angle, just means go clockwise. And then this is a radian one, so just quick review of radians. It's helpful to remember that pi is 180. So something like pi over 6 is 180 degrees divided by 6, which would be 30 degrees. So this is asking us to find the sine of 17 30-degree angles, or 17 times 30 if you wanted to convert it to degrees. I like to think of this as the same as the sine of 5 pi over 6. The reason being, 12 pi over 6 would be one full circle, right? 12 pi over 6 is like 2 pi, and 2 pi is an entire circle. It's 360 degrees. So the sine of 17 pi over 6, well, that ends up being the same as the sine of 5 pi over 6. The angles are in the same place. It's just one full circle later. So rather than trying to figure out what 17 times 30 is in my head, I'm just going to do 5 30-degree angles, because I can figure out where that is pretty easily, right? 30, 60, 90, and then 120, 150. So this is the sine of 150 degrees. And I've already done that on a previous slide, right? 150 degrees is here. The reference angle is 30. I label the sides, 1, negative root 3, and 2. And the sine there is 1 over 2. Okay, because 5 pi over 6 and 17 pi over 6, they are in the same place. They're coterminal angles. And they'll have the same exact sine. These angles are all special because they're quadrantal angles. So if you have an angle that lies right on a axis rather than in a quadrant, like 0 degrees, right? Does this angle have a sine, cosine, and tangent? It absolutely does. The way we did this was to recall our unit circle, or a circle with a radius of 1. And if this has a length of 1, this little arrow that I drew, then the coordinate of this point is 1, 0, x, y. And sine can be defined as y over the radius. Cosine can be defined as x over the radius. And tangent can be defined as y over x. So with just that information, I remember the radius is 1 always in the unit circle. I could answer that the sine of a 0-degree angle, and this would be for part A, right? Sine of 0 degrees is going to be y divided by r, which here would be 0 divided by 1. So 0. The cosine of 0, right, is going to be the x divided by r. So 1 divided by 1, and that would be 1. The tangent of 0 is going to be y divided by x, which is 0 over 1, which is 0 again. And then this is the procedure that you'll use for any of the quadrantal angles. So like skipping ahead to just pi. Actually, we'll just do the pi over 2. Pi over 2 is the angle right here because it's 90 degrees. Pi is 180, 180 divided by 2, 90 degrees. So to do this one, we label the point at the end. It would be 0, 1. That's x. That's y. Radius is 1. And then you go ahead and use the formulas on the right side of this screen to figure out the sine, cosine, and tangent. Y over r, x over r, and y over x, because there is no triangle to use the hypotenuse or the legs of. And then this is just further practice in radians. Evaluate the sine, cosine, and tangent for pi over 4. So pi over 4 is 180 divided by 4, which is a 45-degree angle, right? So 45 degrees, we haven't seen these shortcuts in the video yet. The legs are both 1, in this case both positive because we're in the first quadrant, and the hypotenuse is root 2. And then the sine, cosine, and tangent, right, would be the sine of pi over 4 opposite over hypotenuse, so root 2 over 2 if you rationalize it. Cosine of pi over 4 would be the same, 1 over root 2, or root 2 over 2 if you rationalize it. And the tangent of pi over 4 would be 1. Well, the question goes on to say use that to evaluate the same functions for 3 pi over 4, 5 pi over 4, and 7 pi over 4. That's going to be the same thing in each of the 4 quadrants. 3 pi over 4 is in the middle of the second quadrant. 5 pi over 4 is in the middle of the third quadrant, and 7 pi over 4 is in the middle of the fourth quadrant. And in all cases, the triangles are going to look the same. Makes this little bow tie. Only difference being what's positive and negative. So on the left side of the world, the y values are positive on the top, negative on the bottom, and all the x values are negative. Hypotenuse is never negative. So all you have to do in order to answer the other sine, cosine, and tangents in this question is decide whether the results are going to be positive or negative based on what quadrant you're in. And so there is a little shortcut for that, which was all students take calculus. I prefer not to use this little acronym, and I just use common sense, right, about x and y. But this tells you what's positive. All positive, sine is positive, tangent's positive, and cosine is positive. If it's not positive, then of course it is negative. I forgot to put that there. Or you can just do SOHCAHTOA if you have all 4 of the triangles drawn out and you're figuring out what's positive and negative and where. So that's a quick crash course review in evaluating trig functions, so we can get deeper into trig later in this chapter. And that's all.